Thank you guys for joining me today. I will continue the topic of scheduling in the course of construction planning and scheduling. Previously, in this course, we covered different techniques for planning. I covered bar chart, network models, activity on arrow, activity on node. Also, I covered how to do scheduling for the project, how to set up the timeline for the project using activity on node. In this video, I will set up this schedule using activity on arrow. So how can I construct my scheduling to figure out the early start, early finish, late start, late finish, total float, project duration using the network model activity on arrow. Just to remind you, the activity on arrow means I have an activity, for example, any name. I will write the ID here, and this is the duration of this activity, and this is node number 1, and this is node number 2. So this activity is going from node number 1 to node number 2. Keep in your mind, I will write on this arrow the early start here. If you add early start plus duration, you can get the early finish. If you are moving forward, path. If you are moving backward, path, I will have the late finish. If you subtract late finish minus duration, you can figure out the late start. Keep in your mind the difference between late start, early start, or late finish and early finish. Early finish can tell you what is the total float for this activity. That makes sense? This is if you would like to move backward. Keep in your mind also just a reminder, if we have a node with an activity here, and we are given another 2 activities coming out. So the predecessor, for example, this is A, B, and C. So keep in your mind, if this duration D, so the early start for A plus D will give you the early finish. This early finish will be the same here, early start for activity B and the early start for activity C, because B and C are dependent. B and C has a predecessor A. Then you can add the duration for activity B plus early start will give you early finish. The duration of activity C plus early start will give you the early finish. If you are moving forward, base. If you are moving backward, the late finish of this activity will come back, minus D will give you the late start. The late finish for this activity minus D will give you the late start. Which late start I'm gonna use here? The late start is the smallest late start, because activity A is predecessor for B and C. So if you are moving backward, I'm gonna use the smallest number. If you are moving forward, I'm gonna use the biggest number as we discussed in the previous video. We have few examples. I will start with this project. We are given the activity on arrow network, and we would like to set up the timetable or the timeline for this project. So let's start. I will start this project with activities A, B, C. These activities are the first activities. There is no predecessor. So I will start these activities with early start 0. For activity A, 0 plus 4 will give you early finish 4. For activity B, 0 plus 3 will be the early finish 3. 0 plus 5 for activity C, so the early finish will be 5. D has a predecessor A, so this early finish 4 will be the early start for activity D4. 4 plus 7 will be 11, the early finish for activity D. For activity E, the previous one is B, so the early start is will be 3 plus 6 will be 9. For activity F, the previous is activity C with early finish 5, so 5 will be the early start, plus 6 will be 11. Keep in your mind, for activity H, the previous one is F, so 11 will be the early start, plus 4 will be 15. For activity G, we have two activities previously. Two activities D and E are predecessors. So activity D will give you 11 as early start. Activity E will give you 9 as early start. Which one I'm gonna use? I'm gonna use the biggest one, 11. 11 plus 3 will be 14. So the final duration of this project will be 15, the biggest number. So I can say the total duration of the project will equal 15 days, months, weeks, whatever the unit. So I am done with the forward path. If you start to move backward path, the last activities of the project, which is G and H, will have late finish 15. Late finish 15. Then let's start to move backward. 15 minus 4 will be 11. 15 minus 3 will be 12. This 11 will be 11 here, the same. We have only one following activity H for F. 11 minus 6 will be 5. This 5 will be here 5. 5 minus 5 will be 0. For activities D and E, both of them has a following activity G. So the late start of activity G, 12, will be the latest start for these activities D and E. 12 and 12. 12 minus 7 will be 5. 12 minus 6 will be 6. This 6 will be here 6. Minus 3 will be 3. This 5 will be 5. Minus 4 will be 1. So the final here will be the smallest number. We have 1, 3, 0. So it will be 0. We are good. We have to finish up. If you go backward to the start of the project will be 0. Now, I figured out the late start, late finish for each activity. So I can say the total float for this activity will be 1. The total float for this activity will be 3. The total float for this activity will be 0. For this one will be 1. For this one will be 3. For this one will be 0. This one will be 0. This one will be 1. So we have activities here are critical. The critical activities like activity C, activity F, activity H. Critical activities with total float equals 0. So the critical path will be activity C to activity F to activity H. The last question in this network or in this example, what is the early start, late finish of activity E? Here is activity E. The early start for this activity will be 3. The late finish for this activity will be 12. That makes sense? Let's do one more example. We have another example here. The activity on Aero network is already given, and we would like to set up the timetable for this project. So the first activities in this project are A, B, C. So the early start for each will be 0. 0 plus 3 will be 3. 0 plus 4 will be 4. 0 plus 4 will be 4. We have here dummy. This one is dummy activity. Be careful. So, and this one also dummy. Dummy activity is an arrow without any real task, without any real activity, without any duration, just to define the dependency between activities. So if you start with activity D, the early start will be 3 also. 3 plus 5 will be 8. For activity E, be careful about activity E and F. Both of them are dependent on A, B, and C. Because the finish of activity B the finish of activity A by this dummy activity, the finish of activity C by this dummy activity will be ended at this node. Then I can start activity E and F. So which number here, the early start for activity E will be the biggest number. We have 3, we have 4, we have 4. I'm going to start with 4. For activity E, 4 plus 3 will be 7. And here for F also will be 4 plus 5 will be 9. For activity G, we has only a predecessor C with 4 as early start plus 6 will be 10. For activity H, we have only one predecessor C with 4 early start plus 5 will be 9. Let's talk about activity I. We have two predecessors before, D and E with early finish 8 and 7. I'm going to use the biggest number. 8 plus 6 will be 14. For activity J, we have predecessors with early finish 9 and 10. I'm going to use 10, the biggest number, plus 4 will be 14. For activity K, we have only one predecessor 9, early finish, so 9 will be the early start for activity K and activity L. 9 plus 3 will be 12. 9 plus 5 will be 14. We have here a dummy activity. Will end it here with 14. So we have 14, for 12 or 14, 14. So the biggest number is 14. So the total duration of this project will equal 14 days, months, weeks, years, whatever. So I am done with the forward network. Let's do the backward base. So the late finish for the end activities, I, J, K, L, will be 14. Will be 14, will be 14, will be 14. This is the late finish. 14 minus 6 will be 8. 14 minus 4 will be 10. 14 minus 3 will be 11. 14 minus 5 will be 9. We are good. So we have 11 and 9. I'm going to use 9, the smallest number. For activity H. 9 plus 5 equal 4. We have here 10. It will be 10 as a late finish for these activities. 10 minus 5 will be 5. 10 minus 6 will be 4. For this activity, we'll have late finish 8, and 8 minus 5 will be 3. 8 minus 3 will be 5. So far, so good. For activity A, we have only following activity D, so we will have here 3 minus 3 will be 0. For activity B, I think we should pay attention for this 3 a little bit. It will be 3, but be careful because 3, and we have here coming back 5 and 5. Does that make sense? So be careful about activity A. Does that make sense? So we are going to use the smallest number, which is 3. Minus 3 will be 0. For activity B, we have here coming back this activity was 5, this activity was 5. And also we have here 3 coming back, and we have here 4 coming back. I'm gonna use the smallest one, which is 3. Does that make sense? That we are going to use the smallest one. We have 4, we have 5, we have 3. I'm gonna use 3. 3 minus 4 will be 1. And we have here 4 coming back, and we have 5. So I'm gonna use 4. Minus 4 will be 0. So the final, we have 0, 1, 0. I'm gonna use 0. We are good. So if you look to the total float for each activity, for activity A, we have 0. For activity B, we have 1. For activity C, we have 0. D, we have 0. I, we have 0. E, we have 1. F, we have 1. G, we have 0. H, we have 0. J, we have 0. 9. K, we have 2. L, we have 0. Looks like we have many critical activities. I can say I have critical activities from A, D, I, from the start to the end of the project. I have also another critical activity. critical path. I can say I have C, then G, then G. C, G, and G. I can say I have C, H, L. So looks like I have another one. I think I'm done with all of them. Yeah, we have three critical paths because we have many critical activities in this project. So minimum, we have one critical path, but sometimes we have more. If you have more activities, if you have more critical path, that means the time is very important, very critical, because any delay in one of them you will find a delay in the final duration of the project. The last question in this problem, what is the early start, late finish for activity F? Here is activity F. The early start is 4. The late finish is 10 for activity F. That makes sense? We have one more example. So I will start to set up the timetable for this project. I will start with 0, early start for activity A, early start for activity B, early start for activity C, because these activities are the beginning activities of the project. 0 plus 2 will be 2, 0 plus 3 will be 3, 0 plus 3 will be 3. This 2 will be here 2, early start, plus 4 will be 6, 3 here plus 3 will be 6, 3 here plus 7 will be 10. We will have early start here 6 plus 4 will be 10, 6 plus 8 will be 14, 10 will be here plus 5 will be 15. So for activity J, we will have 10 plus 3 will be 13. So for activity K, we have previous activities J, H, I with 3, 14, 15. I'm going to use the biggest number 15. Plus 3 will be 18. So 18 will be the total project of the total duration of this project, 18. Let's move backward. I will have late finish 18 for activity K minus 3 will be 15. This 15 will be here 15. Looks like I messed up this number. It should be written here. 13. That's fine. This 15 will be here, 15 late finish, 15 late finish, 15 late finish. 15 minus 3 will be 12. 15 minus 8 will be 7. 15 minus 5 will be 10. This 10 will be here, minus 7 will be 3. 3 will be here, minus 3 will be 0. 7 minus 3 will be 4. 4 minus 3 will be 1. We have here 12 minus 4 will be 8. 8 minus 4 will be 4. 4 minus 2 will be 2. By the end, we have 0, 1, 2. I'm going to use 0. Now, I can figure out the total float for each activity. This one will be 2. 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 This one will be 0. This one will be 1. Will be 1. Will be 1. This one will be 0. 0. 0. So looks like we have only one critical path from C, F, I, K. Only one critical path. I'm gonna figure out the early start late finish for activity H. Here is activity H. The early start is 6. The late finish is 15 for activity H. This is 6 early start. This is 15 late finish. Just a reminder, critical activities are the activities with 0 total float. Any delay in these activities will affect the entire project duration. Keep in your mind the critical path can be defined as the network path that has the least slack in common, or the longest path through the activity network, or the shortest time to finish up the project. We have more examples. Example number 4, I would like to create the network from scratch. So looks like we have activity A and B without any predecessors. So I will start my node here. I can uh, rotate this one like this. Yes. So I can start a node here. This is the start of the project. I can put activity A and activity B as the start activities of this project. The duration of activity is 5 and 4 for B. So we have 5 and 4. So I will put a node here and another node here. That makes sense? We have C and D. Has predecessor A, activity A. So C and D. So I will do C like this and D like this probably. Each activity will be ended with a node. The duration for activity C is 3 and D is 2. That makes sense? So far, so good. So the predecessor for activity C and D is A. For E, we have a predecessor B and C. B and C. So how can I make B and C are predecessor for E? So I can draw a dummy activity like this, or I can connect between A and this node, between this node and this node. That's fine. So I can draw here activity E. So activity E with a duration 5 has a predecessor C based on this dummy activity is B also. That makes sense? I think F also has a predecessor B and C with a duration 6. So if you draw activity F like this with a duration 6, I think, yes, will have also predecessor C and based on this dummy activity is B also. That makes sense? The next activity is G. G has a predecessor D and E. D and E. So I can draw dummy activity like this and start to put G like this with a predecessor 8. I'm sorry, with a duration 8. The predecessor right now is E, and based on this dummy activity is D. D and E, we are good. We have activity H has a predecessor D and E also. We have activity H has a predecessor. I can draw it like this. This is activity H with 4. So this activity H has a predecessor E, and based on this dummy activity is D. So D and E, we are good. We have activity I has a predecessor F and G. Where is F? Where is G? This one. So I can draw a dummy like this one between F and G, and then I can draw activity I with a duration 2. Looks like the last activities will be activity H and I. And this is the end of the project. And this is the start of the project. That makes sense? So we can rearrange these nodes, but we will get the same concept. Activity I has a predecessor F and G. So we have G here, but how can I make F as a predecessor? So I draw this dummy activity. Once you set up your activity on Arrow network, then I can start to figure out the timeline or the scheduling of this project. Let's start. Uh, A and B are the first activities, so 0 and 0 are the early start. 0 plus 5 will be 5, 0 plus 4 will be 4. This 5 will be the early start for activity D and C, 5. 5 plus 2 will be 7, 5 plus 3 will be 8. Be careful about activity E and F. Both of them, E and F, has a predecessor C and B. So we have 4 based on this dummy activity, and 8, I'm going to use 8. 8. 8 plus 5 will be 13. 8 plus 6 will be 14. For activity H and G, both of them has a predecessor E and D based on this dummy activity. So we have 13 and 7. I'm going to use 13. 13 plus 4 will be 17. 13 plus 8 will be, I think, 21. Activity I has a predecessor G and F based on this dummy activity. So we have 14, 21. I'm going to use 21 plus 2 will be 23. So the end of the project, we have 17 and 23. So 23 will be the total duration of this project. So the total duration of the project will be 23 days or 23 weeks. And then I will move backward. I will start with the late finish for these last activities, 23, 23, which is the duration of the project. 23 minus 4 will be 21. 23 minus 2 will be 21. I'm sorry here, it's not 21. 23 minus 4 is 19. Sorry. 23 minus 2 is 21. This 21 will be here 21 and will be here 21 also, based on this dummy activity. 21 minus 8 will be 13, I think. 21 minus 6 will be 15. We have here 13 and 19. I'm going to use the smallest number, which is 13 minus 5 will be 8. Based on this dummy activity, we have 19, 13. I'm going to use 13, which is the smallest number, minus 2 will be 11. We have here 8 and 15. I'm going to use the smallest number, 8, and also the smallest number here, 8, based on this dummy activity. 8 minus 3 will be 5. 8 minus 4 will be 4. We have here 11. We have here 5. I'm going to use the smallest number, 5. 5 minus 5 will be 0. By the end, we have 0 and 4. I'm going to use 0. So far, so good. Let's do the total float for each activity. This one will be 0. This one will be 6. This one will be 0. This one will be 4. This one will be 0. This one will be 7. This one will be 6. This one will be 0. This one will be 0, and so on. The total float 0 means critical activities. We have A, we have C, we have E, we have G, we have I. This path is called the critical path. What is the early start, late start, early start, late start for activity E? Where is activity E? Here is activity E. This one is early start. This one is the late start. Both of them are 8s. One more example. Example number 5. So the first two activities in the project are A and B without any predecessors. So I will start with a node here, and I will put activity A and activity B. The duration for activity A, 8 and 9. What is next? Activity C has a predecessor A. So I can draw C like this, with the duration for activity C equals 6. For activity D has a predecessor A and B. So how can I make A and B are predecessor for D? It's very simple. Just to draw a dummy activity like this. That means I cannot start D until you finish A and B. The duration is 8. What else? Activity E has a predecessor B. Activity E has a predecessor B. Only B. Make sure E has only predecessor B. So I can draw activity E like this, with the duration equal 8. Activity F has a predecessor C. Activity F has a predecessor C. So I can draw F like this, has a predecessor C, and the duration for F is 7. The last activity looks like is G has a predecessor C and D. Where is C? And here is D. So I can draw here dummy activity and draw activity G with a duration equal 9. So based on this dummy activity, the predecessor for G is C and D. So looks like the last activities will be F, G, and E. How can I have to construct one node here, which represent the end of the project, and then every last activities like F, G, and E must go to this end. So I will draw here dummy activity to represent activity E will be ended by the end of the project. I cannot draw one arrow to the end. That's fine. So looks like this is the activity on arrow. Then I can start the scheduling. The beginning of the project will be at 0. So the early start for activity A and B will be 0 plus 8 will be 8. 0 plus 9 will be 9. For activity C, the early start will be 8 plus 6 will be 14. For activity D, we have previous predecessors, 2, A and B. So we have 8 and 9. I'm going to use the biggest number, 9. Plus 8 will be 17. Activity E has a predecessor. I think E has a predecessor B. But based on this network, we have also A, which is not correct. Based on this network, E has a predecessor A and B, both of them. And D has a predecessor A and B. D has a predecessor A and B. That makes sense. So how can I make E a B only the predecessor for E? I cannot. So looks like we have here a mistake in the table for the project. E has a predecessor B and E, both of them to be correct. E has a predecessor A and B. That makes sense. So I'm sorry, we have a mistake here. This one should be A and B, both of them. That makes sense. So let's keep going. E will have a predecessor A and B with 8 and 9. I'm going to use the biggest number, 9. Plus 8 will be 17. This 14 will be the same here, 14. Plus 7 will be 21. And G has a predecessor D and C. We have 14, 17. I'm going to use the biggest number, 17. Plus 9 will be 26. So by the end, we have 21, 26 is 17. I'm going to use the biggest number, 26. 26 will be the total duration of this project. Let's move backward. The total duration of the project will be the late finish for the last activities, 26, 26, 26. 26 minus 7 will be 19. 26 minus 9 will be 17. 26 minus 8 will be 18. This 19 will be here. We have 19. We have here 17. I'm going to use 17. If you move backward for this dummy, we have 17. If you move backward here, 19. I'm going to use the smallest number, 17 minus 6 will be 11. We have here 17 minus 8 will be 9. We have here 18. 9 will give you here 9. We have here 18. 9 and 11. I'm gonna use the smallest one. 9 minus 8 will be 1. 9 minus 9 will be 0. I have 1 and 0. I'm gonna use 0. So now I can start to figure out the total float for each activity. We have here 1, we have here 3, we have here 5, we have here 0, we have here 0, we have here 9, we have here 0. So the critical path will be activity B to activity D to activity G. This is called the critical path. What is the early start, late start for activity C? Here is activity C, this one. So the early start is 8, the late start is 11. 8 and 11. The last example in our meeting today, a new project, and we would like to construct the activity on Aero network. So let's start a new example. So activity A looks like this is the first activity in the project. So I will start activity A like this, with a duration equal 4 days. Then the following activities B, C, and D. All of them are following for activity A. We have B, C, and D. So I will put here B, maybe. We have also C and D. You can put the arrangement you are looking for, any arrangement. So B, C, D, 2, 2, 4. 2, 2, 4 as the duration. We have activity E following activity B. We have activity E here. With a duration equal 2. We have activity F following C. I think I need to put here, probably I will connect it to this node, which is activity F with a duration 2. You can try. Activity G is following for activity D with a duration equal 6. So this is G with a duration equal 6 is following to D. That makes sense? Also, we have activity H following to D and with a duration 2. So how can I make it? I can put H here like this with a duration equal 2 and is following to D. We have the last activity I with predecessors E, F, G, H. E, F, G, H. So how can I make it here? So this is activity I with a duration equal 2. And this is the final of the project. So how can I make H also predecessor for I? I think we can make a node here and make sure we have dummy activity like this. Or we can make it smaller like this. This is activity H. And here is the dummy. That makes sense. So you can rearrange your network until you reach to the best one. So this is the end of the project, and the last activity will be I. This is the start of the project. The first activity is A. So I will start with 0, plus 4 will be 4. This 4 will be the early start for the following activities, all of them. 4 plus 4 will be 8. 4 plus 2 will be 6. 4 plus 2 will be 6. This 8 will be 8 here, early start for activity H, early start for activity G. 8 plus 2 will be 10. 8 plus G, the duration for G is 6. This one is 6. So 8 plus 6 will be 14. This one will be 6 also plus 2 will be 8. This one will be 6 also plus 2 will be 8. For activity I have previously 8, 8, 14, 10. I'm going to use the biggest one, 14. 14 plus 2 will be 16. So the total duration of this project will be 16 days. I will move backward. So the latest finish for this activity will be 16. The total duration of the project, 16 minus 2 will be 14. This 14 will be the late start, the late finish for all of these activities. 14 minus 2 will be 12. 14 minus 6 will be 8. 14 minus 2 will be 12. 14 minus 2 will be 12. We have here 12 minus 2 will be 10. We have here 12 minus 2 will be 10. We have here 8 and 12. I'm going to use the smallest number, which is 8 minus 4 will be 4. We have 4, 10, 10. I'm going to use 4 minus 4 will be 0. Then I can figure out the total float for each activity. 0, 0, 4, 6, 6, 6, 0, 0, and 6. So the critical path will be A to D to G to I. This is the critical path for this project with the total float equals 0. Any activity with total float equals 0 will be critical activity. What is the early start, late start for activity F? Where is activity F? Here is activity F. So the early start for this activity will be 6, this one. The late start for this activity will be 12 for this one. So we have 6 and 12. That makes sense? So some of the problem, you need to create the network from scratch like this one, and then you need to apply your scheduling to figure out the early start, early finish, late start, late finish, total float, and then you can find out the critical activity. Then you can decide which path will be the critical path.